All right, this is the Tuesday, November 19th portion of lesson 1.1 on points, lines, and planes. So today you're doing warm-up number 2, which looks like this. If you haven't done it yet, go ahead and take a second, pause the video, and come back. Okay, so the correct answer here is that by the definition of a geometric line, there are no lines in this picture. These are all what we would call line segments because they have a definite endpoint, and lines are supposed to keep going forever and ever and ever. So no lines here. All right, and now we're going to dive right into our notes. So find the note page that is titled 1.1, points, lines, and planes, and it starts with a point is a point is a. That's where you're going to find us real quick. So make sure to write this definition down on your paper next to this part. A point is a specific location that does not have a shape or a size. And we name it with a capital letter. You've dealt with points before on a graph. You know that they look like this. If we see this, we know that that's a point, and that's the name of the point. That's point A. So when we refer to point A, we're talking about this dot with this letter next to it. Not too complicated. So the definition of a line is already right there, so you don't have to copy it down. But a line is made up of 2 points, or at least 2 points, made up of lots of points. It has no thickness or width. Okay, there's only one line through any 2 points. What that means is that when we have 2 points, A and B, there's not just all these infinite little scribbles that we can make. When we talk about a line, we're not talking about that. We're talking about the straight path between those 2 points. Okay, there's only one line that can have those 2 points in it. We're talking about the line that has A and B. It's this line. Okay, and we know it's a line because a line keeps on going. Okay, a line does not have an endpoint. That's why we draw these little arrows, so that we know that this line, even though we don't want to draw it going on forever and ever and ever, we draw the arrows to show that it is a line that keeps going on forever and ever and ever. A line is going to be named either by the two of the points on the line, so we could call this line AB, or if we see a lowercase letter next to it, we can call it line N. So we're going to answer questions 1 through 6 using this diagram. First question, does the name line C describe one specific line? Well, let's find point C. There it is. Now, point C is at the intersection of 2 lines. So if we're talking about line C, that's not very helpful because C is on multiple lines. So no, line C does not describe one specific line. It describes that specific point, but that point is on multiple lines. Number 2, does the name line CD describe one specific line? Yes it does, because there's only one line that holds both C and D. So we could definitely say it's on line CD, or we're looking at line CD and know exactly which line in this diagram we're talking about. Does the name line M describe one specific line? And yes, it does, because of this little lowercase letter, we know that this line we are going to refer to as line M. So that's totally fine. How many points do we need to name a specific line? Just 2. When we're talking about a line, we name 2 points, because 2 points are sufficient by the definition of a line to refer to any one specific line. There can only be one line that goes through 2 points. So when we name a line, we only use 2 points to name it. So line EB, line CE, we do not say line ACE. We use 2 points only. Answer to number 4 is 2, just 2. Another name for line AB, there are no other points on the line, so it's not like we can, this line right here, we could call it CA, we could call it AC, we could call it AE, we could call it line S. But this one, we've only got 2 points that are named on it. So we could call it line AB, or we could call it line N. So that little lowercase letter right there. And that should answer questions 1 through 5. All right. So then we've got another little definition. Collinear points are points that are located on the same line. Points that are located on the same line. That's what collinear means. If 2 points are collinear, they are located on the same line. So, we can go back to our diagram. To answer number 6, we want to name 3 points that are collinear, 3 points that are on the same line. Take a second and think to yourself, which 3 points are on the same line? So there are 2 possible answers here. ACE, they're all on the same line. They're all on line S. And EDB, they are all on line P. They are all collinear. Okay? And the 6B, the last thing on this page, 3 points that are not collinear. Let's see, A, C, and D. D, B, and A. If we throw in 1 point that is not on the same line, then we have 3 points that are not collinear. It doesn't matter if 2 of them are. If the third one isn't, then we can't say that the 3 points are collinear. So ACD, DAC, DEC, any of those would be correct answers for 6B. And turn the page. So now we're going to ask, what is a plane in geometry? And the answer is a flat surface that is 2-dimensional and infinite. We're going to represent this usually with some kind of shape. You'll see in the examples below, there's a parallelogram, there's a rectangular prism. Planes are usually represented with 2-dimensional shapes. Because we can't draw something that's infinite. Just like we draw arrows on the ends of the lines, we draw shapes to represent planes. So they might look like this in an example. And they're going to be named using either 3 points that are on the plane. So if there were 3 points on here, I could name it plane ABC or DEF or whatever the points names were, but you might also see a fancy script letter down at the bottom, so we could also call this plane Y. It's going to be important to look at the letters in your diagrams, because now we have 3 different kinds of letters that are going to be used to name things. Fancy script for planes, lowercase for lines, and uppercase, just plain, for points. And planes hold points and lines. Points and lines can exist on a plane. And that's going to be what we're looking at here. So we got point's like kind of the smallest version we can have. We got a line. A line is made up of multiple points. And a plane is where we can find those points and lines. The plane is the container for those things. Points and lines lie on planes. So here, if you're looking for your example of a plane, this is what you would draw. All right, so now we're going to look at questions 1, 2, and 3. I'm going to look at questions 1, 2, and 3. Okay. So, we are going to, hang on, just let me pause for just a second. Okay, okay, I need to put the rest of this in a second video, sorry.